Example 2, testing hypotheses regarding two population standard deviations. An investor believes that Cisco Systems is a more volatile stock than General Electric. The volatility of a stock is measured by the standard deviation rate of return on the stock. The data in Table 4 represent the monthly rate of return between 1990 and 2018 for 10 randomly selected months for Cisco Systems stock and 14 randomly selected months for General Electric stock. Does the evidence suggest that Cisco Systems stock is more volatile than General Electric stock at the alpha equals 0.05 level of significance? So in Table 4 we can see the monthly rate of return for Cisco Systems in percentages, and over on the right we have the monthly rate of return for General Electric stock in percentage. Now the approach is that we want to know if the evidence suggests that Cisco Systems is more volatile than General Electric. So symbolically, this is represented as the population standard deviation of population 1, which is Cisco Systems, is greater than the population standard deviation of population 2, which is the General Electric stock. So again, this represents the standard deviation for Cisco Systems, and this represents standard deviation for General Electric stock. Now we assume that there is no difference in the volatility or that they are equal to each other. So verify that both variables are normally distributed by constructing normal probability plots, and then we're going to follow steps 1 through 5. So what we're going to do is, if we take a look at our data, so in our stat crunch, we can see that what I've done is I've come in here and we have a title that says Cisco, and then we have GE. So I came in here and I put these numbers in myself. And so what I want to do is I want to graph and then select QQ plot, and then we're going to select the Cisco. And then we're going to add in the normal quantiles on the y-axis. Then we're going to select compute. So if we take a look at this graph, this is all close to that line. So therefore we can say that this is normally distributed. And you can see here that the graph is located here in part A. So this is our Cisco graph. Now let's take a look at the QQ plot for GE. So we're going to select GE and then select our normal quantiles on the y-axis and then select compute. And then you can see again, this data is close to a linear situation. So then we can see here that GE is also normally distributed. So we now know that it passes the first step, and now we can move on to step 1. So the investor wants to know if Cisco Systems is a more volatile stock than General Electric. So this is written as the population standard deviation of 1 is greater than population standard deviation 2. Now recall that the null hypothesis is a statement of no difference, which means this is where the equality is always going to be in the null hypothesis, versus the alternative, and the alternative is the claim stating that we have population standard deviation 1 is greater than population standard deviation 2. So because this is greater than, we can say that this is a right-tailed test. Now, step 2, the level of significance is alpha, which is equal to 0.05. And so what we want to do is, we want to then compute the sample standard deviation for Cisco and General Electric. So in order to do that quickly, we can come back up here, and then we can go ahead and go to Stat, and then go to Summary Stats, and select our columns. So let's go ahead and do both. And we want our standard deviation. So let's bring in our numbers that we get. Okay, so if you take a look here, our standard deviation for Cisco is 11.84%, and the population standard deviation for General Electric is 4.32%. So we're going to take these numbers that we just got from our data. So we have Cisco at 11.84, and so we're going to take that number and square it. And then we have 4.32 for GE. We're going to take that number and square it, And when we divide that, we get the test statistic, which is 7.51. Okay, now we're going to go through the classical approach, doing the critical values. So in order to do that, we're going to go through step 3 here. And we can see that because this is a right-tailed test, we need to determine the critical value at alpha equals 0.05 level of significance. So that means our area over here in the right, since it's a right-tailed test, is 0.05. And so since we have 0.05, we need to find the degrees of freedom in the numerator. Well, since we know that the first population, which means that we have how many numbers in here? We have 10 total numbers. So that's the number in the sample of population 1. So we're going to take the 10 and subtract 1, and we get 9 degrees of freedom in the numerator. And then we want to go back up, and then we want to count, okay, how many items do we have for General Electric stock? Well, if we count up all the data here that we have in GE, we can see that we have a total of 14. But if we subtract 1, that's going to give us 13 degrees of freedom in the denominator. So, since we have 9 degrees of freedom in the numerator, let's take a look. So, 9 degrees of freedom in the numerator. So we have 9 here. Okay, and then we want to take a look at the degrees of freedom in the denominator is 13, but we're going to use 12 degrees of freedom in the denominator because that is the closest. And so therefore, and then we're using the 0.05 significant level. So for 12, we have 0.05, and we're going to go all the way across there. And then what we're going to see is that we have a critical value of 2.80. So we can then see that the critical value here is going to be 2.80. Now, we also know that the test statistic that we found here in step 3 is 7.51. Well, we can see here that 7.51 falls in the critical region. And so therefore, since it falls within the critical region, we're going to reject the null hypothesis. So we can say that there is sufficient evidence to conclude that Cisco system stock is more volatile than General Electric stock at the alpha equals 0.05 level of significance. So investors would use this result to demand a higher rate of return on investments in Cisco systems.